Welcome to everybody to our Wednesday paper lecture series. Today we're welcoming Dave Newman from Colorado State University. And Dave specializes in philosophy of mind and cognitive science. Professor Newman's work covers such diverse topics as ethics of interacting on the web, the relation between chaos theory, emergence, and the mind-body problem, computer intelligence, and whether Aristotle held an emergentist theory of mind. I'll say that one time. Emergent. So today, whether he's willed it or not, he has come to speak with us about the relationships between chaos, free will, and determinism. Would you join me in welcoming David Newman?
I have to begin with a little bit of an apology. This is very much a work in progress, and I haven't spent quite as much time as I would have liked to have spent on it before presenting it to a group, so I hope you'll bear with me. I think I've got some interesting arguments here. They're still in a little bit rough form, and so I'd be more than happy to have you be as critical as you possibly can. That will help me, certainly help me out in making it better in the future. So, what I'd like to do is begin with a quotation from Hume for a couple of reasons. Partly it's to begin, or it's to demonstrate that what I'm saying here really isn't all that new of an idea. I'm sure we're all familiar with the saying that there's nothing new under the sun, and what I'm going to say here really isn't that new. Hume has anticipated me. The other reason to begin with this quotation is that I'll be using it a little bit later to help support one of the arguments. So Hume says, from the Inquiry Consuming Human Understanding, well, that would be from the Inquiry Concerning Human Understanding, Section A, he says, "The most irregular and unexpected choices of men may frequently be accounted for by those who know every particular circumstance of their character and situation. A person of an obliging disposition gives a peevish answer, but he has the toothache or has not dined. Even when an action cannot be particularly accounted for, we know that the characters of men are to a certain degree inconstant and irregular. The internal principles and motives may operate in a uniform manner, notwithstanding these seeming irregularities, in the same manner as the winds, rain, cloud, and other variations of the weather are supposed to be governed by steady principles, though not easily discoverable by human sagacity and inquiry." So Hume, as you probably remember, is a compatibilist, and so am I, and that will come about. You'll see how that works. Libertarians and determinists, of course, are the opposing viewpoints to compatibilists. The libertarians believe that metaphysical free will exists and that we have it. The determinists, short for the hard, sometimes called the hard determinists, deny that metaphysical free will exists. They contend that the entire universe is strictly determined, so any event is strictly caused by some set of previous events. Both groups assert that compatibilism is false. If compatibilism is the view that we have metaphysical free will and that we are determined, they contend that that view is incoherent. It doesn't make any sense. If, on the other hand, compatibilism retreats to some weaker sense of free will, then the libertarians and determinists assert that the compatibilists have changed the terms of the debate and aren't really talking about the same thing that they mean when they say free will. So the libertarians and determinists are presenting a kind of dilemma to the compatibilist. Either you can be incoherent, Mr. Compatibilist, or, Mr. Compatibilist, you can be talking about something completely different. In either case, you haven't really addressed the issue. So in response to that dilemma, I want to assert that compatibilism simply presents an alternate analysis of free will. It doesn't change the subject. By analyzing the concept of free will in a different way, the compatibilist can show that determinism and free will are compatible, and at the same time I can assert that the compatibilist isn't really changing the terms of the debate, because what I'm doing is analyze, there's an existing concept that both we, compatibilists, and the libertarians and determinists share. Concept is free will. The libertarians and determinists propose one analysis of that concept, and I, as a compatibilist, propose another. And by proposing another analysis of the same concept, I want to say I'm not changing the terms of the debate. I'm simply trying to provide an alternative analysis of the same concept. So, my response, my kind of the thrust of my main response to the dilemma presented by the libertarians and determinists is to deny that their definition of free will has any sort of prima facie claim to respectability. Right? If they're going to claim that I'm changing the terms of the debate, they're in some sense claiming some sort of primacy for their definition and forcing me to respond to that. I want to shift the tables on them a little bit and say, no, there's no reason why we should give you that initial leg up on the compatibilist. So once we've gotten off on the right foot, what we really need to do is consider the adequacy of these two analyses of the concept of free will. In addition to considering the adequacy today, I'll try to say a little bit about some reasons why we should think that this variety of compatibilism, the variety that I'm going to defend, is actually true. For that, it will require that I say a little bit about the chaos theory. Chaos theory is a mathematical theory. It's fairly technical. I will do my damnedest not to get too far into the technical details, because I think that the philosophically interesting aspects of the theory can sometimes be obscured by the technical details. If you're interested, I can go into more detail on the math if you like, but I think the philosophy is interesting enough. I don't think we'll need to go there. And finally, I'll try to say a little bit of something about the relationship between my theory of compatibilism and the concepts of morality and ethics. I think there's an argument to be made that supports my claim of compatibilism that comes from that. So to begin, I need to begin repeatedly. But the first thing I need to do then in this sequence of steps is to tell you about the two different analyses of free will that we're talking about. Now, definitions of free will are troublesome. The classic one, and the one that I'll consider as representative of the libertarian and the determinist, is the standard could have done otherwise formulation. So a person's act is free if and only if that person could have done otherwise. I think I'm okay to accept that as the general claim of libertarians and determinists, since many of them will accept that analysis. At the same time, they often will disagree about what that analysis means. It's a modal claim when you're talking about could have done otherwise. And as anybody who's studied any modal logic knows, virtually everybody has a different set of intuitions about what's true in modal logic and what's not true, or even what the modal terms mean. And so the libertarians and determinists have a problem with that phrase, the could have done otherwise analysis. But I'm just going to kind of gloss over a lot of that and accept that that's characteristic of what libertarians and determinists mean by free will. In contrast, my analysis is on the next page. I'm going to suggest that an agent's choice is free in a particular situation if and only if complexities within the agent make it impossible for any finite agent to predict how that agent, the first agent, will choose within that situation. So we've got an agent making a choice, and what I'm saying is complexities within the choosing agent are of such a degree that they make it impossible for any agent, any external agent or the agent themselves, to predict how the agent will choose in response to that particular situation. And I'm going to say that an agent has free will in the most general sense if the agent has the potential to make free choices in that sense. So my first definition defines a particular free choice, and then I'm saying the generic term of having free will is just the ability to exercise that kind of free choice at some time or another. Now, I think the evidence, what I want to do in considering the adequacy of these two analyses is talk about what kind of evidence we have that people have free will. I think there are two kinds of evidence that we can consider for free will. One is introspective, and the other kind is an observation of other people. I coined a phrase the other night, I'm not really sure I like it, but extrospective, by contrast with the introspective. So, in general, with respect to the evidence, I want to suggest that the two analyses are equivalent. In other words, every piece of evidence that would be an evidence for the traditional could have done otherwise formulation of free will also be evidence for the analysis of free will that I present. So I think that just on the basis of introspection and then extrospection, which I'll talk about in a little bit more detail in a minute, I think all of the points of evidence that you could claim support the claim that there is free will be consistent with either formulation or either analysis of free will. What that means is, since the evidential relationship is the same for both analyses, we're going to have to pick one or another analysis on non-evidentiary kinds of reasons. So I'll have some more to say about that later. But let's consider first the introspective analysis. Now, David Hildebrand, in an email the other night, reminded me of a footnote in Hume's inquiry that I had not read in a very long time, so I had forgotten about it. But it's page 63 of the Hackett edition, the 93 Hackett edition, if you're interested. In that footnote, Hume is addressing the fact that an individual may have a feeling of liberty. So this is the introspective evidence that we all have. Hume says, look, a lot of people say, I have a feeling that my choices are free. But he considers the idea that this feeling demonstrates that we could have done otherwise than we actually did. He says, quote, "We consider not that the fantastical desire of showing liberty is here the motive of our actions." So what he's asserting is that whenever we have this freedom, this feeling of liberty or feeling of freedom, we have other motives that we are temporarily ignoring or forgetting about. And so what I think he's really saying is that the introspective evidence for free will is just a failure on the part of the person doing the introspection to consider all of the relevant data. They have a feeling of free will, but they're mistaken simply because they haven't considered all the possible factors that led up to the circumstances at the moment at which they're introspecting. So a little bit later in that same footnote, and along the same vein, Hume says that the feeling of liberty we have is the absence of a determination in our thought processes. So if you remember how Hume thinks about these things, he says that we think in a kind of habitual way. When you see a constant conjunction between one event and another, then you form a habit and a determination that whenever you see the first thing, you learn to anticipate that the second thing will come about. And so what he's saying here is that this determination doesn't exist for some reason in the case of the feeling of free will. You feel yourself to be in a situation and about to make a choice, and there's no habit that's been developed. But the reason there's no habit for you is you haven't had the right sort of experiences yet to develop a habit. It doesn't mean that there's no constant conjunction in that circumstance. It just means that you haven't yet developed the ability to form the appropriate prediction, maybe because you haven't that circumstance enough times before. He also suggests in that same passage that other people who've given the matter more thought can predict human behavior. So he says when you're familiar with someone else's behavior, you can predict it, maybe even better than the person who's doing the behaving can predict their own behavior. Now that's putting us into the realm of not introspective evidence anymore, but the extrospective evidence. But in any case, all of these points that Hume raises in this footnote suggest that the feeling of freedom arises from an epistemic factor, right? An absence of knowledge. And that's the same sort of factor that I'm appealing to in my analysis by saying that it's impossible for us to predict something. That's, again, an epistemic claim. We can't make a particular prediction. Now, in my case, I'm suggesting that, that we have a complete epistemic inaccessibility. So it's impossible for any agent to make the relevant predictions in the case of free choices. Hume doesn't go quite that strong, but I think certainly if my claim is correct, then Hume's will also be correct. That there is an absence of information involved in the feeling of free will. Now, to turn to more recent thoughts rather than Hume's, for myself, I don't think I introspect free will. I introspect reasons, I introspect choices, I introspect attitudes. I don't introspect free will any more than I introspect my reason or any other psychological faculty that I have. What I think that I introspect is the objects of my mental faculties, not the faculties themselves. So when I'm thinking about what happens when I'm reasoning carefully, I see the results of that reasoning. I see premises, I see conclusions, I'm able to introspect those sorts of things. But I don't, at least, and now maybe what I'm doing here is confessing to a kind of inadequacy that other human beings don't share, but when I look into my own mind, I don't see the operation that my reason performs. I simply see the premises and then the conclusions of the argument or something like that. So just based on my own introspective data, I want to suggest that introspection really only gives us access to the objects or activities of our faculties, not to the faculties to themselves. Now, the faculties or the activities that I can introspect include, for example, deliberation, indecision, or indifference. And it's been suggested that deliberation, for example, is a good indicator that somebody has free will. The argument is, now I wish I could remember where I read this argument, I'm going to have to go back and find it, but the suggestion that I heard was that if you didn't have to deliberate, that would be an indication that you didn't have free will. But the fact that you do have to deliberate indicates that there's actually a choice to be made and options to be weighed. Now, I'm not sure that that kind of argument actually demonstrates that there's free will, but what it certainly suggests is that there is a kind of epistemic limitation on our introspective access to free will. We can't really see exactly what's going on when we choose, when we make free choices. I also notice when introspecting that I often don't know what I'm going to do until I do it. It's the same kind of case that Hume was talking about, I think. But in essence, in that circumstance, you or I learn something about my choices the way that someone else does, by watching. So in essence, I take a third-person perspective with respect to myself. I don't know whether I'm going to turn left or right. There are two alternative ways I can use to get from school to my home. I can go right or left when I leave the parking lot, and oftentimes I don't know which way I'm going to go until I actually make the turn. And it's not because I haven't planned it ahead or anything like that. There's just a free choice there that happens. And so my access to that choice is the same as the access that someone who's sitting in the passenger seat of the car would have. So that, again, suggests that my access to my introspective access to my own free will is limited. It isn't the kind of perfect access that Descartes might suggest we have of our own mental states and operations. And so if all of these are true, if there's all of these limitations on our introspective access to our free will, I really think it's plausible that our introspection does not really even demonstrate that free will is present. And if introspective access doesn't really provide good evidence for the existence of free will, then of course it's both analyses that I presented are going to be equivalent with respect to negative evidence. So in short, if you're like me, I don't think that we introspect free will. Instead, I think we infer that we have free will in much the same way that an external observer would infer that we have free will. We generally have much better evidence for what's going on in our own heads than we do with respect to others. But that doesn't change the basic nature of the inference, only the amount of data on which it's based. So in essence, the introspective evidence goes away, and what we really need to consider in analyzing the adequacy of the two stories that I'm considering is the external evidence, the evidence that the third person kind of evidence for free will. And that, I think, amounts to a kind of unpredictability that defies explanation. When you see someone sitting down in a restaurant with a menu, and you're going to try to explain or predict and then explain why they made the choice that they did, I think we're often at a loss. We can make statistical kinds of predictions and explanations of a person's choices. For example, if you knew that somebody is a vegetarian, then you can make the statistical judgment that they're unlikely to choose a dish that includes meat. But having been in a restaurant where a professed vegetarian ordered chicken, even those predictions are only of a statistical nature. They really don't guarantee that, there's not a hard and fast kind of rule that says if somebody professes to be a vegetarian, then they will never order any dish that includes meat. The person in question said, well, you can still be a vegetarian and eat chicken. I don't know what that means. So the kind of unpredictability I'm talking about doesn't arise with every choice that another person makes, but it's particularly evident in cases where we're taken by surprise by another person's action. So a vegetarian ordering chicken was certainly a surprise to me. Those kinds of surprises occur most dramatically when we're dealing with people who are very familiar to us, right? People who we think we know very well, so people for whom we have lots of data. And I even want to suggest that these kinds of surprises happen with respect to ourselves. Sometimes I'm surprised at the things that I order from the menu, and I know myself about as well as anybody does. So, but the thing that's crucial here is because we're surprised, that tells us that the behavior in question was not predicted and probably could not have been predicted. Now, if you consider the first passage that I read, the one by Hume, it's clear Hume thinks that prediction of human behavior is quite difficult also. He there compares the human behavior to weather in the difficulty of prediction. If you follow the weather forecasting, you know how bad weather predictions really are. So it's very, very hard, and we think we're a lot better at it today than we were in Hume's day, but it's still incredibly difficult. And it turns out that that's actually kind of a convenient coincidence for me because the weather is a chaotic system too. And so all of the features that make the weather unpredictable, the mathematical features, are the same ones that I'm going to propose make human behavior unpredictable. So it's kind of neat that Hume pointed towards the exact sort of example that would support my case. So in both cases, in the case of weather and in the humans, we can make these statistical predictions. But we can't predict, we can't usually predict exactly what a human being will choose in any given situation, and we can't predict exactly what the weather will be like. We can make generalizations. The weatherman usually says things like, well, there's a 30% chance of rain in that area. He can't tell you whether or not it will rain on your house, but he can say that within the area that I'm making the forecast for, 30% of the area will get rain and 70% won't. He can't tell you which is the correct 30 and which is the 70, but he has kind of statistical overarching rules. We can do similar things with respect to people. We can say in general that, you know, when somebody gets slapped in the face, they'll react with shock and indignation. But we can't say that with 100% certainty. And we can't predict precisely what words this person would use after having been slapped. So the predictions that we can make are statistical, and that's important because they're not based on the kind of predictive model that we have, for example, in Newtonian physics. In Newtonian physics, you can predict exactly what will happen. If you drop an object at a certain height, Newton's 3 laws enable you to compute as precisely as you like how long it will take for that object to fall to the floor. So these kinds of statistical predictions are more along the lines of statistical mechanics. And that kind of, if you think of that as a model for a moment, that depends on the notion of random actions by large numbers of objects. And that's not the sort of model that we want to use to really explain how a particular human being is making free choices. What we're doing when we're using those kind of predictions, I think, is we're making generalizations over large numbers of people, and then applying that generalization in a particular case to help us deal with the individual, but it certainly doesn't help us to explain what's going on within the individual person. In the same sense that with statistical mechanics, we can't explain what's going on with a particular molecule, if you're talking about ideal gas law type calculations, or you can't explain what's going on with a particular radioactive element when you're trying to figure out when it's going to decay. The statistical mechanical kinds of models don't allow us to do that. So what I'm trying to suggest here is that the external evidence for free will is just as much evidence for unpredictability as it is for some kind of metaphysical free will like the determinists and the libertarians want to advocate. Really, all we have, I think, is a kind of absence of knowledge, an inability to accurately and completely predict what human beings are going to do. Let's see. Yeah, and there's an additional factor here. In order for the libertarians or determinists to propose some piece of evidence that would favor their explanation over mine, what they would need is they would need something that would rule out unpredictability and rule in the kind of metaphysical property of free will that they want to assert exists. But in order to produce that kind of explanation or that kind of case, what they need to suggest is that there is no other factor. There's no causal factor in the physical world that brings about the choice in question. Right? That's the only way they can get to this kind of metaphysical choice. The metaphysical feature of free will is by ruling out every possible physical causal factor that would bring about the choice. But that's a universal negative existential claim. They have to say there is no physical cause that can explain this choice that this person has made. And that kind of claim is going to be very, very hard to support. I think it's commonly said that it's impossible to produce universal negative existentials. Certainly as a practical matter, it's not going to happen. I don't know if it's really impossible in the strongest sense of that word. So because it's going to be so difficult for the libertarian or the determinist to produce a kind of a case that would distinguish my theory from theirs, again, I think the suggestion is that or the conclusion is that the two theories are equivalent with respect to all of the evidence that we can produce. Okay, so that's the first thing is the evidence, either introspective or external, doesn't really give us any reason to prefer one theory or the other. So we need some kind of non-evidentiary reasons to prefer one over the other. And I'm just going to say a couple of brief words about this. I don't really have this worked out in the greatest detail, but my feeling is that any theory that's consistent with modern science is going to be preferable in some respects to theories that aren't consistent with modern science. And the real libertarian theories of free will seems to me are not going to be consistent with the conservation of law of energy and matter and energy. And so I think they have a real big problem that's going to be troublesome for them. Another way of putting this is that the libertarians have to suggest that something is contrary to the principle of sufficient reason. There are events, namely free choices, that are not caused, and everything I think we see in the physical sciences suggests that the principle of sufficient reason, or at least a limited version of it, should hold. So, but then to turn back to my theory, I need to give you some reasons to think that it's actually a plausible account. Okay, I've said the account is that it's impossible for any agent to predict the choice that will be made. So one thing you might ask me is, why should we think that there's anything in the universe that's impossible for any agent to predict? Why should we think that there's anything that has that property? And it turns out that the mathematics of chaos gives us this. Chaotic systems have a number of interesting features. And actually I will draw a little diagram here. The chaotic systems is a system of mathematical tools that enable us to analyze the behavior of different physical systems in the world. The chaotic systems are a special class of physical systems. They have a certain special kind of behavior that's often described, or that is described by what's called a strange attractor. Now, when you're describing physical systems, one way to describe them is to describe what's called their state space. The state space is you just take all the variables and you build up an imaginary dimensional space using those variables, and you see what the system does within its space as it's doing whatever it does. So take, for example, a pendulum. The phase space of a pendulum has in one dimension the speed or the momentum, right? So the direction and speed at which the hinge point is going, and the other is the position of the pendulum at any given time. So we can represent those by two dimensions: the direction and momentum, and the position of a pendulum. As a pendulum swings back and forth, what happens? Well, eventually friction brings it to a stop. So the attractor, the place where whatever you do with your pendulum, throw the bob hard, throw the bob gently, tap it with your knuckle, whatever you do to the pendulum, in the end, the pendulum is going to end up at rest with its momentum zero and its position right in the middle. So that has what's called a point attractor. A single pendulum has what's called a point attractor. If you take a pendulum and you take away friction, you have the same sort of state space, but then you're going to get what's called a limit cycle attractor, where depending on how hard you push the pendulum, it will swing constantly around. It will, when it swings to in one dimension, it always comes out to the same height as you started it. It comes out to exactly the same height on the other side, and it will do that forever. Again, this is a frictionless pendulum. And so that can be described by what's called a limit cycle. Now there's another kind of system, if you take two frictionless pendulums and swing them at different rates, and if their rates are not an integral multiple of each other, you get a weird kind of state space, which is really hard to draw, because I have to draw it in 3 dimensions here. It forms the shape of a torus or a donut. So imagine, I'm not much of an artist, imagine this is a donut shape. What happens is the smaller diameter of the donut, so if you slice the donut in half, the diameter of that section is one of the frictionless pendulum's limit cycle, and the direction around the larger diameter of the donut is the other frictionless pendulum's limit cycle. Because the two, if you've got them at the right frequencies so that they're not an integral multiple of one another, it will never come back to the same place on the donut again. Okay, so this has the interesting feature of being what's called aperiodic. This is periodic. It comes back after a fixed set of time. It comes back to exactly the same place. This is periodic. Period 0, it comes back to the same place all the time. This one is aperiodic because the system never, the two pendulums will never come back to the exact same state that they started in. All 3 of these kinds of systems can be analyzed using everyday average sorts of physics. These are very well understood. They can write differential equations governing these, and they can solve them. The 4th kind of system does not have that property. They cannot solve the differential equations for chaotic systems. And again, I'm not a very good artist, but what typically happens in a chaotic system is you get aperiodic behavior, but it's not limited to a kind of donut shape in this sense. There isn't, this has 2 periods in it. Even though the system as a whole is aperiodic, you can see that there's still the period of one of the pendulums in it and the period of the other pendulum. There's still, those periodicities are still there, even though the system as a whole is aperiodic. In chaotic systems, there isn't any periodicity at all. Typically, or one typical kind of the most famous strange attractor, and the only one that I have even a hope of being able to draw anything like, is the so-called Lorentz attractor. And the Lorentz attractor has 2 kind of spiral forms, and I can't really draw it in 2 dimensions, but because it's a 3-dimensional shape, they're not parallel to another, they're hinged in the middle. And what the system is doing in this kind of this kind of system is, it starts spiraling around one side, and then at random and unpredictable intervals, it reaches a path that crosses over to the other side, and so it spirals around the other side for a while. And again, at random and unpredictable intervals, it crosses back over to the first one. So there's no, and so the periodicity is completely gone. It's not going, these cycles are not all uniform in each of these lobes. They're of different sizes. Some of the loops are bigger, some of them are smaller. And they cross over from one lobe to the other at random and unpredictable times. So this too is aperiodic. This is a strange attractor. So how does that get us unpredictability of the kind that I've suggested, this kind of absolute and total unpredictability? Well, the features of chaotic systems that give rise to this, or the crucial feature, is what's called sensitive dependence on initial conditions. Any 2 points in this system, of any, however close together you want to make them, after a little while, they will be far apart according to the dynamics of the system. In other words, if you make a tiny little error in measuring the state of the system at some initial time, and then you try to predict where the system will be at some future time, your tiny little error will grow dramatically. It will grow so rapidly that pretty soon, within just, in some systems, within a second or two, the system could virtually be anywhere, and you wouldn't know. So the unpredictability comes about because the only way we could predict these systems is if we could measure their initial state with essentially infinite precision. And since we can't measure anything with infinite precision, we can't even write down numbers with infinite precision. We just can't measure them effectively enough. We can't compute with numbers of infinite precision. So we cannot make effective predictions of what chaotic systems are going to do. So that's the first point, is these kinds of physical systems exist, and they have the kind of unpredictability that I need to support my claim about free will. And I haven't mentioned any yet, but I'll tell you two simple systems that have this property. One is a frictionless hinged pendulum. So if you take a pendulum and you put a hinge in the middle of the bob, it will have this property. The other one, believe it or not, is a dripping faucet. Okay? The rate and frequency with which drips fall from your dripping faucet, not under all conditions, but under some conditions, you can play with how wide open the faucet is, but under some conditions, it's impossible for anybody to predict when the next drip will fall. So very simple systems have this. But even more importantly, there's good reason to think that our brains have this capability, have this property. There are two sets of evidence. There's EEG evidence, and there's a ton of different researchers who've done the EEG evidence. But you know how EEG works. They put electrodes on your brain. They put them on the outside of your skull, and they record the electromagnetic waves that your brain is producing. Well, by performing the right kind of mathematical analysis on that data, people are able to demonstrate that brains have this property. Even more impressively, to my mind, there's a result by a fellow named Freeman and his coworker Skarda. They did some work on rabbits. And what they were doing is trying to learn about how rabbits' sense of smell works. And it's kind of gross, but they open up the rabbit's brain and they put a little set of electrodes, sensors, right on the part of the rabbit's brain that does olfactory sensing. Right? In humans, we know that different parts of your brain do different things. We know, for example, that the part back here is where you do all your visual processing. Same kind of thing is true for rabbits. Rabbits, though, smell is really important to them, so they have a big olfactory bulb. It's really easy relatively easy anyway, for the researchers to put a sensor array right on the rabbit's olfactory bulb. And they were able to show that this kind of thing is going on in the rabbits whenever they sense a different smell. Okay. Now, assuming that rabbits and humans are both mammals, and so assuming that our brains are roughly similar, this is probably pretty good evidence that the same sort of thing is going on in us. So if the math shows that we get unpredictability in chaotic systems, and if there's good evidence that human brains have the dynamics of chaos, then I think it's pretty good reason to think that we have in our brains the kind of unpredictability that I'm asking for with respect to free will. The other interesting thing about chaos is I think it shows us something that's a reasonable model for human behavior in some respects. So this is kind of a simple attractor. There are two lobes, and you have one state kind of going on over here, and then at random times the system changes over to another state in this other lobe. Well, the model that I like to use in thinking of this is think of those as emotional states, or mental states of any kind, but emotion I think is a good model here. You're happy, yada-da-da-da, everything's great, and then for some unknown reason you get sad, and you go over to the other lobe. And then you're sad for a little while, and then something, you don't really know what happens, some unpredictable time, you stop being sad and you're happy again. Okay, that's a very crude kind of model. Psychology is obviously not bipolar in that sort of way, but strange attractors can have more than just two lobes. The only reason I use this is because it's easier to illustrate. We could imagine lots of different lobes, and the transitions between them would become very, very complex. And I think we can use those different lobes in the strange attractors as models for different mental states. Emotions is easier, but I think the story can be extended to other mental states as well. Okay, so we've gone through the adequacy issue with respect to the evidence, and I've talked about some technical reasons to think that humans have the right sort of unpredictability to support my analysis of free will. The last thing I want to talk about is the moral aspect. And I think this is still fairly crude, but I want to note that responsibility is a kind of epistemic concept. In other words, when we attribute responsibility to people, we assume that for a particular action, we assume that they knew or could have known the consequences of their action. We don't hold people responsible for the consequences of actions that they could not have predicted. So you wouldn't say, somebody flips the light switch, and that's the flipping of the switch that throws the circuit breaker that causes all of New York to lose power. We wouldn't hold that person responsible because there's no way for them to have known that flipping that switch would send the system into blackout. So if it's impossible for an agent to anticipate the consequences of a particular action, we don't hold them responsible for those consequences. Similarly, if it's impossible for another agent to predict the first agent's behavior, then we don't hold them responsible for the first agent's behavior. Right? If we knew that somebody was an axe murderer, then we might be held responsible for not locking him up somewhere to prevent him from committing any future axe murders. But if we couldn't predict that this person would perform future murders, then that's in some sense what makes them responsible for their actions. It's the fact that we can't anticipate what they're going to do. So responsibility, I don't want to claim that it's strictly an epistemic concept, but it has a large epistemic component. It is closely related to the concept of free will. Somebody can't be held responsible for things that aren't done freely. So this is a part that I think is kind of slippery and I'm a little bit worried about, but it seems to me it's plausible that if responsibility is an epistemic, or at least partly an epistemic concept, and responsibility implies free will, then free will must at least be in part an epistemic concept. And since my analysis of free will is largely epistemic by contrast to the traditional could have done otherwise formulation, I think that this is a reason to prefer my analysis, a non-evidentiary kind of reason to prefer my analysis to the other one. Now, that isn't to say that I'm trying to say free will is strictly an epistemic issue. I think there is a metaphysical aspect here, but we have to be careful about what it is. These kinds of systems are metaphysically distinct from the other three. These are complex in a way that those other three are not. So what I want to suggest is that's the metaphysical thing that we're pointing at when we talk about free will. It's not some mysterious, unknown property that we can't really point at. It's something like this. And finally, the last thing I want to mention is a common objection that's raised to any time I mention any of this stuff with respect to trying to analyze human behavior in chaotic system terms, There are, of course, other physical systems, non-human systems, that are chaotic. And of course, I don't want to say that dripping faucets or hinged pendulums have free will. So I think the way I gave the analysis of free will at the beginning, I termed it in, I phrased it in terms of agents, certain particular properties of agents. Now, I don't know what an agent really is. That's something that, that another kind of avenue that I need to investigate. But I think it's clear that a hinged pendulum and a dripping faucet is not, those things are not agents. So by that kind of subterfuge, maybe it's not a subterfuge, at any place, by that kind of promissory note, I've tried to rule out things like dripping faucets and hinged pendulums from having free will. But I do recognize that that's a problem, and unfortunately all I can say right now is, well, I hope that an analysis of agenthood will solve that problem for me. So to wrap it up, there were, I think, three reasons to support the analysis of free will that I gave in terms of absolute unpredictability. The first is that the evidence on both, any evidence that you could consider supports the two theories equally, and so from there you go to non-evidentiary kinds of considerations, and I think the unpredictability account is superior in that regard. Secondly, there are good reasons to think that human beings, who I think we all regard as free agents, have the right kinds of physical properties to give us the kind of unpredictability that I've proposed. And thirdly, there's the epistemic aspect of responsibility, which I think suggests that we should prefer an epistemic analysis of free will, or at least one that respects some epistemic aspects of free will rather than one that's strictly metaphysical. Thank you.
Well, we have time for questions. Why don't we take just a quick 5-minute break? There were some things to eat.
David suggested that I could moderate my own questions if I was comfortable with that. I'm okay with that, provided you all don't jump in at once.
Yeah. Jump up and yeah.
So questions, comments, reactions?
Actually, I had a question about this.
Sure.
Now, you said that these are metaphysically distinct, mostly from complexity, say,
Right, well what I'm saying is that we can analyze different physical systems using, there's one set of mathematical techniques that you use to analyze the system, or any of a number of different systems. When you do that, some systems you find fall into this category, some of them fall into this category, some of them fall into this category, and some of them fall into this category. It seems to me that's an indication of kind of, we have a four-way metaphysical distinction here. This is talking about the mathematics of those systems, how they behave. So it's metaphysical in the sense of their dynamics or the behavior of the systems. It's not metaphysical in the sense that hinged pendulum is still, physical matter, just the same way that a non-hinged pendulum is, but the hinged pendulum behaves differently. And since I want to include kind of those kind of dynamic properties as among what's metaphysically real, I think this does make a distinction, a real metaphysical distinction.
I mean, each of these can be described by a certain differential equation, right?
Well,
not necessarily a solvable one.
Right, any physical system can be described using differential equations. Their behavior, dynamical behavior can be. And what happens is when you solve, in essence, when you solve the equation, this isn't really solving it in the same sense that when you plug numbers in and then you calculate what some other number should be. This is solving it in the sense of you're seeing what does that differential equation really tell me about the behavior of the system. And in some cases, all the behavior goes to a point. In some cases, it goes to a loop. In some cases, it goes to this weird donut shape. In some cases, it doesn't do any of those things, and it does. I mean, the diversity of strange attractors is huge. There's very many different shapes and forms of those.
this, the definition issue that you brought up at the beginning.
Uh-huh.
I'm not sure where that all ended up, as far as these two different definitions of, to be, for an action to be free, so it could.
Two different analyses.
Right,
Right.
and what determines the propriety of one or the other in this case?
Okay, the phrase that I was using was the adequacy,
Mhm.
right? And so normally, when you have definitions dealing with kind of physical things, one sense of adequacy has to do with whether it's evidentially adequate. In other words, does this analysis meet what we see in the real world, so to speak? And my claim there was that the two different definitions were evidentially identical. So all the evidence for one would be evidence for the other, and vice versa. There was no case in which you could point to a particular circumstance which would favor one of the definitions over the other.
And in the case of the unpredictability of some of these different kind of systems, right, is the claim that they're unpredictable because of our limited epistemic capacities, or?
Well, there's a slight distinction here. Just with respect to the definition of free will, I didn't make any particular, so in the definition of free will, I didn't make any attempt to explain where the unpredictability came from. I just set a standard for what level of unpredictability was required. It isn't until I got into talking about, well, why should we think that definition is, what kind of non-evidentiary kinds of reasons can we have for preferring that? And one of them is, well, does it fit with what we know in the other areas of science?
Okay, and in those other areas, does chaos theory say that these things are unpredictable in principle? I mean, if you sort of postulated an infinite intellect, would these things be unpredictable to it too?
Well, no. They're unpredictable to any finite agent.
Mm-hmm.
So if there were a Maxwell's demon, or C.D. Broad calls it the mathematical archangel, if there were a Maxwell's demon or a mathematical archangel who could do two things, who could measure things with infinite precision, and who could perform computations with numbers of that precision, then such a person could, or such a being could, make the appropriate predictions. But in terms of our physical universe, there just isn't enough matter in the universe to perform that kind of measurement or computation. You would need more matter in your computer than there is available in the universe to perform those kinds of computations.
So that's an argument against there being a mathematical archangel?
No, it's just, all I'm willing to say at this point is that the kind of free will I'm talking about is unpredictability for any agent within our universe. If there is,
That we know of.
That we know of.
Yeah, right.
Well, but no, actually it's going to be any agent within our universe. The mathematical archangel or something supernatural, and I'm not worried about that.
Oh, okay, so within the natural world.
Right.
But the natural world itself, right, is predictable, not just for anyone in it.
Well, right. If you want to include in predictability the idea of these mathematical archangels or Maxwell's demons.
Yeah, because I'm just thinking, are there laws governing the natural universe?
Yes.
And in this case, there are, right?
Yes, and that's the sense in which I'm a compatibilist, right? I'm saying, look, our behavior and the behavior of any chaotic system is governed by deterministic laws.
Mhm. We just can't know them.
We just don't know. Well, we can even know the laws. We just can't measure precisely enough to use them in making predictions.
So in that case, then, they couldn't have done otherwise.
Right.
Right?
Right.
Okay. Because, so the definition of freedom that you're using then, it's at least the metaphysical implications of it are different than that could have done otherwise.
Yes, the metaphysical implications are different, but I guess what I'm saying is, but the real world implications are not different. And I mean, I guess my issue is I don't know how to, you know, I don't know how to detect metaphysical differences, and I guess here I'm showing some of my kind of, what's the phrase I want? The pragmatic leanings, or some of my leaning towards requiring
That makes a
operational definitions of concepts.
I am completely sympathetic to this kind of compatibilist approach because I'm a Leibnizian, so I'm all over it. If you could do an infinite analysis, then you would know.
Yes.
But now we've got, for every finite agent, a necessary condition for free will.
Right.
But we have no sufficient conditions. So could you say a little more about where you're going? I mean, otherwise, because then dripping faucets would have free will and so would weather.
Right.
So you want to say, or can you? I know that you're not clear.
Well, the
but
problem is what is an agent?
Mhm.
Okay, and so I think if I can, I think what the condition is going to be is agency plus this kind of absolute unpredictability gives free will. I think that'll be the sufficient condition.
Okay, yeah, but all right, that's going to.
But I don't really know how to analyze what it means at this point. I don't know how to analyze what it means to be an agent, other than, I mean, I can say the kinds of things that, you know, that are philosophically commonplace. Agents are actors, stuff like that. But I don't know how to cash that out in a way similar to cashing this out in the kind of, so, you know, I don't, yeah, we have a metaphysical concept of agent, but I don't yet have the operational definition of what it means
I'm
to be an
interested
agent.
in would you have an intuitive inclination whether you would make Data, the robot, a being with free will?
It would depend on how complicated he is. He certainly
Okay, let's
meets the
say you can meet that
he certainly meets the agency
Oh.
criterion, right? I mean, I think he meets the agency criterion.
See, I was thinking the other way. Okay.
Well, I mean, on our
Because a
everyday.
positronic brain has got to be wired chaotic. I just
Sure,
think
but
so.
on our everyday understanding of agents, right? Data seems to me is an agent. Now,
I guess I
I think
wonder
here's the tough problems with respect to this are going to be things like, you know, start going down the phylogenetic tree, right? So, dogs, yeah, they're probably agents. Yeah, they probably have free will. Go down lower, rabbits, cats. Well, I don't know which one of those lower, they're probably the same. But let's go down to, say, reptiles. Probably not, I don't think so. And part of the reason I don't think so is I think their brain is too different. I don't think it has this property. So the question, it just occurred to me, there is a test. Well, it doesn't test the analysis. What we can do, though, is test certain beings to see whether their brains are chaotic or not, and that would at least indicate to us whether it was possible for them to be free or not. So if you put your super brain scanning machine on the reptile and it said nope, it's not chaotic, then you go up a little bit higher. What's higher than birds, maybe? You know, okay, and maybe you might even get different results for different species of birds. So Tweety the parakeet does not have chaos, so it can't be free will, but you know, somebody or other, the African gray parrot maybe does.
Going back to the early part of the discussion, when we were considering the quality of the evidence, both intro and extrospective.
Right.
So you cited for the introspective thing, the example of pulling out of the parking lot, am I going to turn right, am I going to turn left?
Right.
I don't know until the last minute.
Right.
How do you handle someone who says, gee, that might be your introspection, but mine is totally different. I do know that I'm going to turn left, and I do turn left.
In some cases, you know, I mean, I admit that in some cases I do have foreknowledge of what I'm going to do, and all I was trying to do, point out with that case of the not knowing, is to point out that at least under some circumstances, we are epistemically limited with respect to our free will. So the fact that we're epistemically limited was all I was trying to show, is that we don't always introspect our free will in the kind of perfect way that Descartes would suggest. And because we can't do that, right, what I'm trying to do is draw, this is a kind of a loose argument, but what I'm trying to do is draw out the epistemic limitations that we have with respect to free will and suggest that, well, if we've got all of these epistemic limitations with respect to free will, then clearly that's an important aspect of free will, and so I think that's a reason to go in the direction that I'm going. But even more importantly, at the end of that, I said, look, in essence, I'm not even really sure that we introspect free will. We introspect the results of free will, but not free will itself. So in the end, I guess I'm more inclined just to say that introspective evidence is a wash, because in both cases, doesn't really mean very much. Yes, sir.
I'm having a hard time seeing how you can avoid driving just a huge wedge between free will and responsibility if we cast free will in the terms that you're asking.
How do you mean?
Well, it seemed, you even alluded to it at the end, you suggested that we're held responsible for our predictable actions, but the predictable actions would be precisely the ones that aren't free on your model.
Oh, no, I meant to suggest that we're held responsible for actions where we can predict the consequences. Okay, so all I meant to suggest there was, again, responsibility has an epistemic component. I don't mean to suggest that it's strictly epistemic, or that the kind of more powerful thesis that you suggested. All I wanted to say is, look, there's something epistemic going on in responsibility. And if responsibility is crucial for, or if free will is crucial for responsibility, if the two go together in a tight enough way, then the fact that there's something epistemic about responsibility suggests that there should be something epistemic about free will as well. And the reason to make this kind of argument at all is, again, to kind of defend myself against the libertarians and determinists who want to say, no, free will is a strictly metaphysical concept. There's nothing epistemic about it.
So your claim is that we should understand responsibility strictly in terms of consequences, not in terms of the action itself.
Not strictly, but I want to say that it's certainly necessary that we understand the consequences of an action, or at least the ability of the agent to predict the consequences in order to understand whether the agent is responsible or not.
There's something that was bothering me about that too. Is that I'm thinking that this might be the sort of thing you're thinking of, is that if the free stuff is the stuff that's unpredictable, and that's the stuff you're responsible for,
right?
Then why couldn't I say, and there must be something, there's got to be wrong. Why couldn't I say that? Well, I knew I was gonna go chop up my neighbors with an axe.
Yeah.
So I'm not responsible for it. You know, does that mean it wasn't free because I
certainly
knew I was going to do it? Whereas if I wasn't sure, then it was
think about
free.
cases where we think freedom fails, right? So why is it that we that we put the criminally insane in mental asylums rather than in jail? It's because we think they're not responsible. And why are they not responsible? It's because they're ill. And what's the illness? Well, the illness includes the idea that they have this, now I don't know if this is actually a case, but you could imagine a weird kind of psychosis in which anybody who sees the color purple immediately attacks that person with an axe. Okay, so, and that's certainly predictability, and it's the kind of thing that we say absolves the ill person of responsibility.
But so it is completely sporadic.
Yeah, exactly.
Complete randomness, you mean?
Yeah.
Yeah, well now in some ways these are not completely random, right? If they were completely random, we'd get into the realm of those kind of statistical predictions where you'd be dealing with bell curves rather than this kind of thing. You'd be dealing with summations over large numbers of events, and in this kind of case it might be large number of choices of a particular individual.
Yeah, but they may not be random. I mean, we may perceive it that way because we're far more ignorant than we think.
Mm-hmm.
But it certainly could be some sufficiently complex causal system that results in their doing things which could never be predicted by anybody anywhere because they have different reactions to, I don't know.
Right, but it depends, here's the crucial question for me. What is the cause of the unpredictability? If the cause is something like this, then that's, I think, along the lines of what I'm trying to propose. I mean, that would support my claim. There is a kind of causation of randomness that would not support my claim, and that would be more along the model of, say, radioactive decay, right, where you have a whole bunch of events, they're all occurring with a kind of fundamental quantum randomness, and then the only way to analyze them is using a statistical analysis over this huge number of events. That would give rise to unpredictability too. But I don't think, for one thing, I don't think that's what's really going on in us. And for another, if it were, that would certainly be a problem for me because I don't think that kind of story allows, I mean, that, we still can't explain the individual decay of an individual radioactive element. And so in that, to draw the analogy, then we couldn't explain the individual actions that a person made because they would be completely random. And I don't want to say that doesn't sound like free will to me. So I guess what I'm saying is if that's the source of human unpredictability, then yeah, then we don't have, then we don't have free will in my sense.
But I still don't see why it couldn't just be a case of sufficiently complex behavior, so we don't know why it is that we can't predict this person's maniacal assaults. They may appear to us to be random or something, but they're actually not. I mean, we wouldn't be able to distinguish those two, right? And so we're going to sort of arbitrarily say that, okay, if the causal nexus is like this.
I think we can distinguish, just in the same way that we're able to determine that what's really going on in quantum mechanics is this kind of fundamental quantum randomness. That's something that can be determined scientifically. And I'd say if that was what was going on in human behavior, there would be some way to determine it. I mean, how did they figure out, what kind of tests do they perform to verify the kind of quantum randomness hypothesis? I'm not enough of a physicist to know what those tests were, but I was under the impression, perhaps mistaken, that they had performed that kind of test, something having to do with statistical analysis of Geiger counter results or something like that.
Gamma spectroscopy is typically what's used, and what you do is you just pick one random setting, and you count on that, and you'll just get random results every single time.
Right, and so you
It'll be
plot them and you get a bell curve.
Yep.
Right, and I think if you plot choices that human beings make, you won't get a bell curve. So that will suggest that it's not random in the way that quantum randomness is. And so I think your choices will be determined by what the strange attractor is. And now it is mathematically, it's very hard to figure out exactly what strange attractor is present in any given system. But there's a convenient feature of chaos that even if you can't figure out exactly which one is present, you can get a kind of, there's a class of similar attractors that all have the same general shape, but they're not exactly identical to one another. And you can determine that a physical system is in the class even if you can't tell exactly which one it is. So this thing is kind of like I said, kind of has an angle to it. You can imagine there's a bunch of them kind of all stacked up next to one another, these two-lobe attractors. Well, in the chaotic system, we can't measure the system precisely enough to determine which exact one of these strange attractors is really present, but we can measure it precisely enough to determine that it's one of those and not some other attractor.
So any one of those would do?
Any one of them will do in terms of our ability to make the rough kind of predictions of human behavior that we in fact do make. Right, because they're all the same, because they're all roughly similar, we can make a kind of generalization over all the different attractors and say, well, in general, to use my kind of oversimplified psychology, in general, people are either happy or sad. Kind of, that level of generalization will be possible. Still, I guess I'm not fully understanding the thrust of your question. If I haven't answered it, I'm not, it means I'm not really getting it, I guess.
Well, maybe you have. It seems to me, though, that there is there could be some number of different kinds of sufficiently complex systems that would work in the minds of a maniac, in the minds, I mean, because I don't think that people who we call just sort of criminally insane are, sometimes they're incredibly predictable.
Yeah.
And so
Other
I don't.
times they're not.
Yeah, and sometimes their actions seem to be absolutely unpredictable.
Yeah.
And so I just don't see how
Well,
we're
yeah,
gonna do
you
the
know,
responsibility thing. I just.
Yeah, my intuition was driven primarily by the ones that are predictable. And so I guess maybe I should think harder about the issue of responsibility. But it seems the connection has got to be something having to do with whether or not there's a law governing the person's behavior. If there is, then we might know the law or we might not. If there is and we do know it, then clearly we can say, well, this person is criminally insane, and we can predict what they're going to do, and we damn well better put them away. If it's in the other case, the person is doing really horrible things, but we can't figure out what the law is, then we might be in some doubt about whether or not the person is really criminally insane. We might say, so there would be presumably be some kind of big argument with testifying psychologists on both sides in the court case, and one of them would say, well, yes, he's criminally insane and he should be put in an asylum, and the other one would be saying, no, he's just an evil man and he should be given the death penalty or some such. So I guess if we don't know, if we can't figure out what the law is, then it's an open question whether or not the person is really responsible. Now, if there was a law that we didn't discover, then I guess my approach would be to say, well, they're not really responsible, and regardless of whether we can figure it out or not, they should have been put in an asylum. Yes, sir.
Yeah, I just want clarification to tie in with the question about responsibility and free will. Now, take just the free actions. You're not saying that when you come to free actions, they're totally unpredictable. That's not the position. Or are you saying that when it comes to free action, they are not totally predictable?
Right.
And then there is a degree of predictability, and you assign, when you come to free actions, and you assign accountability according to the degree of predictability of that particular action. Is that how you?
I guess I would say free actions are predictable. We can, they are, it's impossible to predict precisely, every time 100% what a free agent will do.
And they don't have the same degree of predictability. What varies from one action to the next.
Right. What we can do is make statistical predictions that are independent of the actual cause of the behavior. So the actual cause of the behavior is going to be this, something like this. But we may be able to say, well, 50% or 75% of the time, this person is over here in this lobe, and 25% they're over in there. So that would allow us to make a kind of statistical prediction about the relative frequency of being in those two different lobes. And that kind of thing we could make predictions. Then we could say, well, 75% of the time, a person who's slapped by a man who's slapped by an angry woman, blushes, or something like that. Well, that's not a good choice because that's not a free action, but responds with an insult. Okay. Then we can make predictions at that level, but we have to recognize those are statistical generalizations over something that we can't really make a precise prediction.
But then we still sound a bit odd that doesn't jive with our normal notions about responsibility. We assign accountability not statistically by looking at other similar actions, like this particular action.
Right.
Right? But in your account, you have to look at all the other actions, so it's still.
Well, how do we, when we're looking in the commonplace view, when we look at a particular action, how do we note whether to assign responsibility to it or not? So take the case again of the criminally insane. If we just come into the room blind, we've never seen this person before, and they do something really wacky, then we might say, a certain extent, we might say to ourselves, well, that's so wacky that I now have the hypothesis that they're criminally insane. But we couldn't make the actual judgment until we'd seen them perform similar actions repeatedly. So even in the case of responsibility, I think we look, the evidence is that we look at multiple cases. That's not to say that the real truth of the matter isn't, right, the real truth of the matter is determined in one case, and I think that's true of my story too. It's just, so we have to, what I think we have to do is distinguish whether or not the person really is free, that's going to be determined by this, from our everyday interactions with them, and the level of prediction we make in everyday interaction doesn't necessarily connect with the kind of predictions I'm talking about for this.
No,
Right, see, we've got two different sorts of predictions that we make about people. One is just the kind of everyday statistical prediction. You know that in general, people who are hungry go get something to eat. And you can predict what somebody will do when they say, oh, I'm hungry. You can then predict, oh, I bet they'll go to eat. But then, right, if you then learn, but if then they immediately follow that by saying, but I'm on a diet, so I can't, then you're going to change your prediction because now you've got more information. That level of prediction is independent of the kind of prediction I'm talking about, where the idea would be, follow that person around every moment of every day, collect as much data on them as you can, try to formulate a precise psychological model for them. Can you then predict what they are going to do? And my claim is then under those circumstances, because the prediction is foiled by the fact that the person's free actions are made on the basis of strange attractors.
but then it still seems to me, I'm sorry, it still seems to me that even if you're right about freedom, the fact that I learned after doing that analysis tells me nothing about why I should assign responsibility to them. I mean, it gives me no moral reason whatsoever to assign responsibility to them, and presumably.
Okay, so you're suggesting that if we discover that a person their behavior is indeed controlled in this way by a chaotic system, and that's what makes it unpredictable, that doesn't tell me whether to assign responsibility or not.
It doesn't say why I should. I mean, you're saying that it's the indicator that I should, but it doesn't tell me why I should. And presumably, one of the reasons I say I assign responsibility to you is because you are free.
Right,
You were
well,
free to do
the
it.
sense of responsibility is going to be slightly different from me than it is for the metaphysical free willists, right? I mean, because they're in essence saying responsibility is a kind of metaphysical property dependent strictly on having this metaphysical property of being free. And I'm denying that. So yeah, there is a sense in which I'm saying that responsibility is different from the way we've traditionally thought about it.
Well, okay. Although actually a different kind of compatibilist could use the notion of responsibility I just employed. One that would say you're responsible because your action was determined
Right.
by your desire,
By
by
your
something
desire,
that you.
okay, that's right.
So
Right.
yeah. So, but I'm sorry, I interrupted. You had a question.
No, I was going to change the subject a little bit. I'm not
Okay.
a philosopher, but I'm interested in evolution. And in as much as these models are representations of some natural reality, you talk about periodic and aperiodic
Right.
models. And I'm reminded of Schrodinger's What is Life?
Uh-huh.
If I understand it correctly, the periodic system is a good model for physical systems.
Yeah.
Aperiodic for biological systems. So my question is, from your understanding of the literature on chaos, or what people are saying about it, are these strange attractors, are they supposed to be representing more just various more complex biological systems, or do you think that they're representing, as I think you alluded to earlier, some kind of psychological, system that, as you said, it's beyond our present ability to predict?
Well, chaotic systems occur in all different domains of science. You'll find them in purely physical systems, not biological ones. So like the hinged pendulum has this property. The weather has this property. In fact, the famous Lorentz attractor was first discovered by a guy who was investigating weather patterns. So it happens in physical systems. They do also happen in biological systems. So the brain, I think the evidence is pretty good that brains have that, but they're not the only, not remembering offhand, but there are both physical and biological.
Maybe I should rephrase it to say that what are the distinctions of the levels of complexity that you might be able to draw between these different periodic, aperiodic, and the strange attractors?
Well, both of these two are periodic, and both of these are aperiodic. And I would say, really, I'm only trying to make a distinction in complexity between this one and the other three. And the distinction in complexity I'm trying to make comes about simply because these are the only ones that require us to measure and compute with infinite precision in order to understand what they're going to do. All of these others have the feature that, say, let's imagine you have a certain measuring device and you're putting it onto a system. And your measuring device has an error, right? It can measure within plus or minus 1 or plus or minus 2 of whatever unit it is. Well, that unit, that plus or minus, then you perform your computations to predict what the system will do. The measure of error stays constant, or at least it grows linearly through your computation. The problem with chaotic systems is that measure of error grows exponentially through your computations. And so the complexity lies in the fact that the system behaves in a dramatically different way. The math of this kind of system is dramatically different from all of these three, which is reflected by the fact that the error measure grows exponentially here, but it doesn't in any of those three. Does that answer your question?
I think so, yes.
Okay, good.
So what you access in this side is, in the end, because of that, a simpler outcome, and that's kind of an indictment of psychology across the board. I mean, hitherto, right?
Right.
We've always used, I come from the psychological side, so we've always used statistical distributions, plus or minus, within plus or minus
Yes.
1. This thing that you just said really helped complete the sentence. So the systematic error, that's good news in a way, it makes it simpler, but it renders the outcome
Simpler
less
than it really should be.
simpler than it should
That's
be.
right. That's right. I would say that psychology in general oversimplifies because they don't recognize that what's really going on is a chaotic system.
And so that if we got really good at this side,
Yeah.
we could have, instead of generalized population statistics, we could have individual.
Yeah.
we could
But
have-
there will.
yeah.
That's right. But there will always be an epistemic limitation on what
Yes.
psychology can do with respect to the individual, because we can't measure things precisely enough, and we
Yeah.
can't compute with that level of precision.
These models like this,
Yeah.
we buy ourselves quite a bit more given
Yeah.
the object that we're
That's right.
analyzing.
And in fact, I mean, I'll just allude to something else that I've been doing, which is more psychological, and it ties in with the rabbit research. I think that this is a good model for qualia. So I think that I can explain a lot of the features of qualia by like their the fact that they're inexpressible. Well, it comes because in order to express them, you'd have to be able to say things you'd have to be able to say infinitely long sentences. And so that's, I think, another advantage to this, and that's actually where I came from, is thinking about the mind-body problem and the quality problem and all of this, and the free will thing kind of popped out as a side thing from that.
Well, if there are no other questions, why don't we thank Dave for an excellent presentation.